Hello everyone, welcome back to Knowledge Bytes. In our previous episode, we learned how AI converts text into embeddings, which are numerical representation of meaning. But have you ever wondered, once these embeddings are created, how does AI searches through millions or even billions of them in just few seconds, right? That's exactly what we are going to explore today. In this episode, you will learn about the vector search, similarity search, or vector databases, and basically the technology behind the ChatGPT recommendation engine, semantic search, or retrieval-augmented generation, that is a RAG. So that's where we are going to learn today. Let's get started. So before we move forward, let's quickly revisit what we learned in last episode. So when you type a sentence like "I love AWS AI," the embeddings models convert that sentences into a list of numbers called an embeddings, right? So these numbers capture the meaning of the sentence. Now imagine an enterprise storing 100 million embeddings from a documents or emails or PDF or product catalogs or customer conversations. These obvious questions becomes, right? So how does AI find the right one almost instantly? That's the problem we are going to solving today. So let's understand why traditional search isn't enough. Suppose you are searching for how can I reset my password? The traditional keyword search only looks for the exact words, right? Like reset and the password. It might completely miss the document's title, like forgot your login credentials or account recovery guide. Even though these documents answers to your questions, the wording is different, but AI search work differently. Instead of searching for the words, it searches for the meaning. So this is called the semantic search, and it's powered by vector search, right? So what exactly is the vector search? Vector search doesn't compare words. That's where we should remember. It compares the embeddings. So here's what happens. First, your words, your question is converted into an embeddings. That's where. So then these embeddings. So AI compares those embeddings with millions of stored embeddings inside a vector database. So instead of looking for exact matches, it looks for closest vectors. Those closest vectors represents documents with similar meanings. The most relevant documents are returned to the application. And finally, AI generates the best possible answer. That's where the ChatGPT often understands what you mean, even when you don't put the exact words, right? So now let's understand, so what is similarity search? So how does AI decides which vectors are similar, right? That's where the similarity search comes in. So think about using Google Map. So if you are searching for a nearest coffee shop, right, Google Maps calculates which locations are closest to you. AI does something very similar way. So instead of comparing the physical locations, it compares the embeddings. So vectors that are close together usually represents similar ideas. Vectors that are far apart represents different meanings. For example, if your question is about resetting a password, AI might retrieve the documents like password reset guide or forget password or account recovery or change login credentials, because these are all represents the same intent. Similarity search is really the heart of the modern AI retrieval. Let's understand the different similarity methods, or these are the several ways for AI measures the similarity. So let's keep it simple. The first method is Cosine similarity. It compares the direction of the two vectors rather than their length. So this is most commonly used method because it focuses on the meaning. The second method is Euclidean distance. Think of it as measures the straight line, right? A straight line distance between 2 points. So the third method is dot product, which means how well two vectors aligned. So for the AWS AI practitioner exams, remember this. Cosine similarity is the most popular similarity metric for semantic search, right? So now So what is a vector database? Now we know how vectors are compared, but where are they stored, right? So inside something called a vector database, a traditional database stored structural informations like the customer name or email or phone number or order date, so order ID, so all this, right? So vector database is different. So it stored the embeddings, so metadata, so and relationships between the data. So more importantly, so it's optimized for finding similar vector extremely quickly. So that's where the important, right? Without vector databases, modern AI applications simply wouldn't scale as on today, so as we are seeing today. So now let's understand popular vector databases. So these are the several popular vector databases available today. On AWS, Amazon Open Search Services, Open Search Service provides built-in vector search capability. If you are already using the Postgres SQL, so you can use the pgvector extension. Other popular platforms includes like Pinecone or Weaviate or Milvus or and Chroma. So don't worry about memorizing every product, right? So the important concept is that they all solve the same problems: storing embeddings and performing the fast similarity search. So now let's understand the real world applications where we are going to use this vector search. So where is the vector search actually used? So almost everywhere. ChatGPT uses it to retrieve relevant information before generating the answers, right? So Amazon uses it to recommend the product, whatever the similar products to the customers who are buying the similar products, right? Or Netflix recommends the movies based on viewing preferences, or enterprises companies use it to the search millions of the internal documents, or healthcare organizations use it to the find the similar medical cases, or image search systems find visual similar images. Every time AI understand meaning instead of the matching keywords, vector search is usually involved. So let's get understand AWS architecture level. So let's see how all these works on AWS. So your documents are first stored in Amazon S3, and embedding models such as one available through the Amazon Bedrock converts those documents into the embeddings. Those embeddings are stored in Amazon Open Search service using a vector index. When a user asks a question, the same embeddings model converts the query into an embeddings. So OpenSearch perform a similarity search and return the most relevant documents, and those documents are sent to the large language model. Finally, the LLM generates an accurate answer. This architecture forms the foundation of many retrieval augmented generations, that is RAG solutions on AWS. So let's understand the AWS exam corners. So, right. So let's test your understanding with the quick AWS AI practitioner question. A company stores millions of documents embeddings and wants to retrieve the most semantically similar documents for the user query. So which technology should they use? So option A, relational database. Option B, vector database. Option C, object storage. Option D is data warehouse. Take a moment and think about it. So the the correct answer is B. So that is vector database. So now why is the vector database? Because the vector database are specifically optimized for storing embeddings and performing fast similarity searches, right? That's exactly what semantic search requires. Key takeaways. Let's summarize today's learning, right? So embeddings are represents the meaning of data, and vector search finds the most similar embeddings. Similarity search ranks those embeddings based on the closest or closeness, right? So and vector database stores and retrieve the embeddings efficiently. Together, these technologies power semantic search. recommendation systems, or AI assistants, or enterprise search, and retrieval-augmented generation. This is a very most important concept we are going to learn in future the episodes. These are the fundamental concepts for the modern generative AI. Now, let's come to the end. In our next episode, we will explore one of the most fascinating concepts behind the large language models, that is the context window and attention. So, once AI retrieves the right information, how does it decide which parts are very important? How does how does it focus on the right words while ignoring less relevant information, right? So that's exactly what we will uncover in next episode. If you found this video helpful, please like, share, subscribe to Knowledge Bytes. Thank you. See you in next episode.